My name is Karthik. I'm going to do a project report out for machine learning foundations for product managers. The objective of this project is to perform a modeling process and predict the target variable with a given other independent variables. The Excel has been given with the data, so we will have to use the Excel, find the right model and do the modeling process. So here we are going to use a multiple linear regression algorithm for the model processing. Since the data is numerical and there are multiple independent variables, we will be using a multiple linear regression algorithm for the prediction. So the approach we are going to take is that given data set will be divided into training set and the validation set. 80% of the data will be training set and around 20% will be the validation set. So there are four different independent variables has been given. So first model you would develop with all the four independent variables. After that, with the correlation of the target variable with the independent variable, we will select the best suited independent variables and build another model with only three variables. And we will validate both the model with the validation data set. And finally, we will compare the result and derive with the conclusion. So this is the Excel data which has been given for prediction. So there are four independent variables here, and we wanted to predict the P, which is our target variable. So first, I have divided this independent variable into two data sets. As I said, around 80% is for training set and another 20% is for validation set. So I have used Excel to calculate the values. I have used multiple linear regression algorithm. So here you could see that the algorithm has calculated the multiple R value and R square, and eventually given the prediction against each observation and the residuals. Okay, right? So here you could see this is the predicted value and this is the residuals. So with this, I have calculated mean absolute error, mean square error, and mean absolute percentage error. So here we could see this is the average value of mean absolute error, mean squared error, and mean absolute percentage error. You can see the value here. So, and here I have calculated the correlation of the independent variable with the target variable, and we can see the first two variables are well correlated with the target variable, whereas the rest of the two variables are a little away from the target variable. So for the next training set, we will just consider only the first three variables, and we will not use RH for the modeling. So here you could see that there is a multiple R and R square value which has been calculated, but we could see that this is better. The training set with all the variables is better than with these three variables, and eventually the mean absolute error, mean square error, and absolute percentage error. Here we could see that the errors is bit higher when you compare to all the training set with all four variables. And we could see the similar pattern for the validation set as well. You could see the error here. And you could see the error rate here, which is a bit higher. Similarly, we could also observe that R square value is also better with all variables when you compare with the three variables here. So here I have also done the calculation for predicting the new value. So you can just enter any value here and it would give the new prediction. Now you can go to the performance evaluation. So here this is the correlation with the target variable, and you could see that these two variables are well correlated with the target variable, and this is the results. So the training set with all the four variables, we could see giving us the better results when compared to any of the other models. And also the error rates is better with all the four variables when compared with three variables. So finally, we can conclude that the model with all four variables is better when compared to the rest. Thank you.